as to how the ellipse is generated. You have 2 points, and then you connect a string to these 2 points. By the way, these are going to be called the foci, all with which we don't care. But that's what they are, and they're inside. And then here's the picture. You take a pencil. This is loose string, much like the circle. You take your drawing implement, and then you pull it tight. That'll be your first point. And then what you do is you go around, and what happens is that string shortens and lengthens on either side as you go around the ellipse. And that's what makes it oblong. With a circle, the string is fixed. So if I think about a circle, I have the center, the string's at center, and then we come out here, and it goes around. This is a fixed unit. But as I go around, one side will lengthen, like this guy, as I move over here, this side lengthens, this side shortens. So it's not fixed distances. The total distance of that piece of string across is fixed. Now, if I think about an ellipse, by the way, is oval in one direction or the other. It can be either elongated along parallel to the y-axis or elongated parallel to the x-axis. If I take a look at the ellipse, the longest side, we'll look at this guy, longest side, is called the major axis. So this guy here, elongated as a major axis. On this particular parabola here, this is the long side, so that's the major axis. So it says the length, the guy where the ellipse is the widest, that's called the major axis. And this, where the ellipse is the shortest, is called the minor axis. And so it's the short side. Major versus minor. And then we have the center. And guess what the coordinate point of the center is? What letters do we use? HK, yeah. And depending upon, and I don't like to memorize formulas, the distance from center to what this thing is called as a vertex, right? We could call just A. Distance from center to this, what we call, this is also a vertex, is B. Like R is to the circle. By the way, these guys here at the ends of the major and the minor, these are all vertices. I was watching Jeopardy last night, and they had plurals. What's the plural of matrix? Matrices. I knew that. And what's the plural of vertex? Vertices. I knew a lot of the plurals. I did good on that one. So when I'm going to graph it, I'm going to be interested in the length from center, just like with the circle, from the center to the edge of the vertex, both directions. And that's pretty easy to find, by the way. Now, what is the standard form for the ellipse? The standard form for the ellipse is x minus h squared over a squared plus y minus k squared over b squared equal 1. If you had to guess, if I got rid of a and b, that's the circle. That would be a circle. But in this particular instance, this is the ellipse. Now, what are A and B? A and B is the distance between the center and the edge of the ellipse. So from the center to the edge is A. From the center to the edge is B. I don't care who's bigger or who's smaller, that all takes care of itself. Your book will get into that. They'll switch A and B, I don't care. You don't need it. The longer is the major axis, the shorter is the length is the minor axis. Now if I look at it in general form, I'll have ax squared plus by squared plus cx plus dy plus e equals 0. Now what makes it an ellipse and not a circle is this right here. A is not equal to B. That means that the distance from center to a vertex is not the same. If you go from one direction to the other direction, the distance from the center to the vertex isn't the same. So if A equals B, that says the distance from center to the edge, distance from center to the edge is the same. That's what makes it a circle, because the radius is constant. But in this particular instance, it says A isn't equal to B. So that means that essentially the distance from center to a point on the ellipse or to a vertex is different. That's what makes it either elongated this way or elongated this way. The other thing, I don't worry about this, by the way. I don't care what that is. This is your transformation. From 0, 0. So that's your transformation. However, this is what tells you that's also an ellipse. First of all, A is not equal to B. Secondly, I notice that the coefficients of x squared and y squared are positive. So coefficients of x squared and y squared are positive. The other thing you have is you have both x and y squared. So both x and y are squared. The coefficients of x squared and y squared are both positive. And that's the same for that and a circle. What makes this an ellipse is that the coefficients of x squared and y squared aren't the same. They're the same, it's a circle. If they're different, it's an ellipse. So I mean, a circle is a special case, really, of an ellipse.